Consider the quartic polynomial r of z is z to the 4 minus 6z cubed plus 17z squared minus 22z plus 14, and p of z, which is z squared minus 2z plus 2, where r of z is p of z, z squared plus az plus b. So in other words, this quadratic here is a factor of the quartic here. We want to show that z minus I minus 1 is a factor of p of z, and we can do that by evaluating p of 1 plus I. So that would give us 1 plus I squared minus twice 1 plus I plus 2. So let's do 1 plus I squared. So that's going to give us 1 plus I plus I plus I squared. I squared is negative 1, so that just comes to 2I. So that's going to be 2I, take away 2, take away 2I plus 2, which is equal to 0. So that does that using the factor theorem. We now want to solve the equation r of z equals 0. So let's do it back in the space here so I don't have to keep going up and down. But we have z to the 4, let's just get the other colour pen, z to the 4, take away 6z cubed, minus 17z squared, minus 22z plus 14. That is going to be equal to z squared minus 2z plus 2. And then we'll have another quadratic factor. Now because this is a z to the 4, that's got to be a z squared, and we were told it was up here anyway. This is a 2 here, this is a 14. That tells us we must have a plus 7 at this end. The only thing that we're not sure about is the middle one. And we could compare coefficients, say, of z cubed to do that. So on the left we've got negative 6. What's going to give us a z cubed on the other side? So we would get that one would be a z cubed, so that would be k. And that one. So that would be a take away 2. And that gives us that k is negative 6 plus 2, which is negative 4. So we have z squared minus 2z plus 2 and z squared minus 4z plus 7. And from this one, we know that 1 plus I was a root, and therefore 1 minus I would be, remember, real coefficients, so therefore conjugate pairs. So this one just gives me 1 plus or minus I. And then we have to think about this one here, which we could solve using maybe the quadratic formula. So z is going to be 4 plus or minus the square root of 4 squared, take away 4 times 1 times 7, all divided by 2. So that is going to be 4 plus or minus the square root of 16 minus 28 divided by 2, which is 4 plus or minus the square root of negative 12 over 2. So 4 plus or minus I, and root 12 is root 4 root 3 over 2. So that is 4 plus or minus 2i root 3 on 2, which would give us 2 plus or minus I root 3.